Unit 6, which is about the experiment, the alternative to practical. We did the first two questions from this. So question 3 is there. A student investigate how the volume of an air, volume of an air in a syringe vary with the pressure. She plots a graph of P against 1 over V as shown. So there's a graph between the pressure and volume, and P and 1 over V, it's a straight line passing through origin. Determine the gradient. So how to determine the gradient? You have to take any 2 points, not the points which are used to plot the graph, any other 2 points, and use the formula gradient equals to y2 minus y1 over x2 minus x1. And you have to show that the points which you are taking on the graph. The next one, investigation. The investigation is carried out at a temperature 25 degrees centigrade. Calculate the number of the molecules of air in the syringe. So how we can find the number of the molecule? So we have the formula PV is equals to NKT. So using this formula, PV is equals to NKT. So temperature should be in Kelvin. If we need the number of the molecules, it will be PV divided by KT is equals to N. This is for part B. So PV is equals to NKT, or if we want the number of the molecules, number of molecules is PV divided by KT. So you can use any, like example, when we work out the gradient, you have this formula like PV is equals to NKT, or I can say P is equals to NKT divided by V, or I can also say P is equals to NKT multiplied by 1 over V, because we plot a graph here. As you can see, our graph was on y-axis we plot pressure, and then on x-axis we plotted 1 over V. So 1 over V was x-axis, y. So what will the gradient of this graph? The gradient of this graph was NKT. The gradient of this graph, like our previous answer, which was a gradient, equals to NKT. So we have the gradient. We have this K is there, which is a constant, 1.38 into 10 power minus 23, and temperature is there. So gradient divided by KT is equals to number of the particles. Is it clear how we work out the number of the particles? The next question, student places two polarizing filters. This is related to polarization. He notices that when he rotates one filter relative to the other, the intensity of the transmitted light changes. When the plane of these polarizing filters are parallel, so the light maximum amount will pass horizontal. The light from the lamp is unpolarized light, the light which is having multiple components of vibration. So when the planes are parallel, only one component will pass. But if the planes are perpendicular, as a result, there will be no light or light intensity decreases. State why the student should keep the distance between the filament lamp and the light meter constant. Like why this distance should be constant, why he should not change this. Because what happens if we rotate the polarizing filter, that will change the light intensity. And if the light source and the detector are, the distance between the light source and detector changes, that will also affect the light intensity. So the reason why this distance, because we are investigating, he notices that when he rotate the filter, the light intensity change. So we just want to investigate how rotation of the filter can alter the light intensity. So we should keep the distance between the light meter and the lamp constant, because the light intensity can be affected by So light intensity can be affected by distance between the lamp and the meter. State the main source of uncertainty in this investigation. So what is the main source of uncertainty? Because it's not like maybe in the surrounding we have any light source, maybe sunlight is there. So that will lead to uncertainty. The experiment may not be accurate. So main source of uncertainty for this experiment, maybe a light source is there or light from the background or light from surrounding. The relation is there between the measurement of a light intensity and the angle theta is given, where K and N are the constant. Explain why the graph between L and I and ln cos theta should be a straight line. So what we'll do, we'll take ln both sides. When we take ln both sides, so it will be ln I is equals to ln k times cos theta into n. In log, whenever, or if you take log ln, you take or log. Log is a base function, means the base is 10, and ln is base e. So if we take log both sides, so according to log, if a multiplied by b is there, we'll write as log a plus log b. When two quantities are multiplied, we write them in addition. So it will be log I equals to log k plus log cos theta times n. And if log a raised to power b is there, how we write? We write b log a. Like that will become coefficient. So it will be log I is equals to log k plus n log cos theta. If we rearrange the equation, so we can say log I is equals to n log cos theta plus log k. And when we compare with the equation of straight line, like on y-axis, if we plot log I, and on x-axis, if we plot log cosine theta, our gradient will be equal to n. So if gradient is equal to n and dimension n and k are constant, so it will be a straight line which is passing through, not passing through origin because there is a y-intercept. So there will be a straight line, but it will have a y-intercept. If the graph is there between log I and log cosine theta. Is this clear? About the graph? Then student records the following data. Lux is actually a unit of light intensity, which is also known as a candela or lux. So theta is there, cosine theta. So it will be, this will be log I, and the unit, whenever we write the table must be with a column heading. So this is log I and the unit is lux, and the other one is log cosine cos theta. So we have to take log of this and write here, and we have to take log of cos theta, which is 0.86, and write it here and complete the value. Then we have to plot a graph from these values results and determine the value of n. How you determine the value of n and k? As we already did, this whole graph was there between. You can see this graph when we plot, the gradient will be equal to n. So when we'll have the graph, we'll find the gradient taking 2 points using y2 minus y1 or x2 minus x1. That will give us a value for n. And what about the y-intercept? What y-intercept represent? The y-intercept represent the value for ln k. So ln k will be equal to y-intercept, like any value is there, the 3. And then you will take opposite of this, like and shift, you will press, because we want k. To get the k, we or log. So log k is equals to certain value of a y-intercept, And then we'll take anti-log. When we take anti-log, so it will be k is equals to 10 raised to power 3. It will be like this. This is just an example, like the y-intercept example 3.2. So we'll take anti-log, so it will be anti-log of 3.2 or 10 raised to power 3.2. That will give us the value for k. From the graph, we have, this is space for the graph. So 4 questions were there in this paper.